Hey guys, John Palermo here. Once again, back from a 2-month hiatus. I think it's been about 2 months since I've put out. Oh no, I digress. I did put out a video just recently on the CBM PET 8032 coming to Canada, so I lied. But in terms of the series here, let's make a Commodore 128 game. It's been a while since I've released the last part. That was part 2, and today we're going to discuss part 3. So what I wanted to do today is just go over the basic framework for the game. We've already looked at or talked about a little bit about bank switching and memory management. So now let's just go into the code and start looking at our framework. And I don't know if I'm going to do it in this episode, but perhaps in the next episode, I'm going to show you my game concept, the theme, the plot, the game mechanics. Okay, so I'm pretty excited to share that with everyone. And again, this is going to be for the Commodore 128. So let me just, and I apologize, I can't get this GoPro. I'm a bit cheap. I'm using a GoPro as my webcam. It's cutting off my chin here because I've got to look at the screen. So this is a bit low tech at the moment, but I hope you can see my VS Code window. And of course, I will pop over there. Okay, you're going to probably see me looking downwards. That's because the GoPro is so high. So anyway, enough of that stuff. Let's get into it. So, let me clean the window up a bit. Okay, so here we're looking at the base assembly language program. That's what I called it, base.asm. And I'll show you what I've come up with so far. Okay, so let's just say that this is like the main game loop. Okay, but before we get into our game loop, we have to do some initializations. Now, in a previous episode, I described to you how to inject assembly code into the Commodore 128, similar with the Commodore 64. Let's review this. So again, at the start of every assembly language program, you want to have this little piece of code. And here I've called it Basic Upstart 128. Let's go in and review that. So what this does is it puts binary data, byte data, starting at location 1C01. On the Commodore 128, this is the start of BASIC. Not entirely true. The start of BASIC is at 1C00, but that is always 0, and we don't put any basic code there. So we actually start at 1C01. And so we say, put the program counter at 1C01 because that's where we're going to start putting bytes and words. So the first word, we need to tell the basic interpreter where the next basic command will be following the next one. I don't think I said that. So this basically tells BASIC that after the next command, this is where the next command starts. Does that make sense? So here's where the next command starts after the one we'll be reviewing right now. So anyway, the next word is basically the basic line number. So we'll choose basic line number 10. Quite common. The next byte is the basic code for sys, the sys command, right? So the basic interpreter will interpret this hex code 9E as the sys command. And we all know that a sys command is followed by a physical address in memory. So following that, we will put in the next several bytes, we will put the address that we want to put our assembly language code in, right? Just recall that the sys command basically passes control over to, the machine language mode, if you will, the Commodore 128. It will not run BASIC. It will run machine language. So we're saying, okay, like run this machine language program at this, starting at this address, but it's expecting the address to be in string format, in ASCII, right? String format. So we're going to use this kick assembler function to int string, not sure why it's called that, and pass the address. So that will convert the address to text. Now, every basic statement must be followed by a 0 byte, and that's what we're doing here. And then finally, as we've told basic, this is where the next basic command starts. But to tell basic that we're done with a program, we put two zeros. So the next 2 bytes will be zeros, which signals the end of the program, right? And now we change the program counter to this address, which is basically the end of our little basic program. If you do the math, you count all the bytes from this address to the end of this word, you'll get this address here. And that's just a review from one of the past episodes. So that's kind of setting up our what we call our basic upstart. I'm going to close this. I think Kick Assembler's having some issues here. Okay. So let's, hopefully it still, okay, it still likes my thing. Okay, so we talked about the basic upstart 128. You'll always have this at the start of all of your assembly language programs. And then we start our initialization. Okay, now we've talked about the MMU, the Memory Management Unit on the Commodore 128, and how it's very important on the Commodore 128 because it uses, the Commodore 128 has 128K of RAM. And the 128K of RAM is basically comprised of 2 banks of 64K. So there's two RAM banks. The first one is RAM Bank 0 or RAM 0, and the second bank is RAM Bank 1 or RAM 1. Now, not only does the MMU register control which RAM bank the C128 should use, but also different memory. It allows us to have different memory configurations. That is, switch in RAM, switch out ROM, switch in or out the I/O and the kernel. So the designers of the Commodore 128 made it a little bit easier for us to set different memory configurations, and that's a nice thing. So what I've done is I've created a macro called libmmu set bank config, and I'll explain what this does. And again, if you recall from a previous episode, it's all about the bank configuration, and the MMU allows us to set the bank configuration. And Kick Assembler is really going nuts on me right now. I'm not sure why. Here we go again. This is something. Text hover over failed. Okay. Let's just move on here. So, I won't go into the specifics, but I have made some comments here about what each bit does. And so let's ignore all those errors for now. All right, this has not happened to me before. I'll figure that out at some other time. So, okay, so here's the macro, and what I've done is there's the designers of the Commodore 128 have provided a set of 16 bank configurations. Not, yeah, I mean, you can set the bank configurations various ways, but if you're going to set the MMU control register, which is FF00, address FF00, then you can really play around with the bits on your own. So you can have more than 16. And in fact, I've created my own configuration, and I called it ID 16, but that's configuration 17 out of the 15. So let's go through some of the common ones. Bank configuration 0 basically has no ROMs, and we're all RAM, and all RAM 0. Bank configuration 1 is no ROMs and all of RAM 1. And ID 12 is internal function ROM, kernel IO RAM 0. So I think you get the gist of this, right? So these various configurations allow us to swap in and out, or switch in and out ROM, RAM, kernel, IO, and things like that. So I've conveniently created this bank ID 16, and you can see here custom RAM bank configuration not defined in the books. You won't find this in any of the books. But what this does is allow me to switch in IO. By default, IO is switched in, so I have IO. I still have the kernel. I have RAM 0, right? So we're not gonna worry about RAM bank 1 for now. We have enough in RAM 0. There's gonna be no basic because we don't want to use it, but we have the kernel if we want to run some kernel routines. And at the end, we have 48K of RAM left over. Okay, so we have lots of RAM, and we don't want to switch out the kernel. I may use some kernel routines. And we definitely don't want to switch out I/O. We want to keep I/O because that's where the VIC registers are located as well, right? So, enough of that. Let's go back and continue with the program. I'm really hating these errors. I have to figure out why that's happening. Maybe my kick assembler config is not correct. I might have done something. Anyway, let's move on. So there we have it. So I hope now we can kind of see the benefit of having the MMU configuration register, or the control register, sorry. And I've decided that I want to have my own. So, and it will be a benefit later on. So now the next thing I want to do is I want to get out of VIC Bank 0. I want to get out of there because that's a very busy area of memory. It's a very busy area of memory. There's the 0 page. There's some kernel routines. There's for the Commodore 128. There's some basic. I think if I recall correctly, there's some basic in there. But anyway, it's an extremely busy area. So I want to get out of that area and into an area that is more free of RAM. And since we switched out basic, right, which is a big chunk of what's in VIC Bank 1, like there's a lot of basic ROM in there, we switched it out. So when we switch to VIC Bank 1, then we'll have a lot of RAM available to us, right? And VIC Bank 1 is from 4,000 hex to 7 FFF, okay, so which is a block of 16K. Now, again, I just wanted to show you the basic framework because in the next episode, we'll start getting more into the mechanics of the game and start building sprites, and start moving sprites around, and then start building our own character map. So it's going to get more exciting, but I just want to show you the basics for now. And I think I'm repeating myself too many times already. I like to educate by emphasizing and repeating things, so I hope that doesn't bother you at all. So again, so what's something basic that we want to do? We want to change the border color. I'm going to change the border color to blue. And for many of you, this is pretty basic and simple, and you're probably getting bored, but I want to make this or these videos accessible to complete beginners. So if you're a complete beginner, I just want you to understand what's happening in the game. So here I'm going to set the border color, and it's quite simple. We load the VIC register. It's not allowing me now to. So there's an error here somewhere. Let's have a quick look. Yeah, I don't know what this is all about, to be honest with you. Maybe one of the viewers can tell me. But essentially, what we're doing is loading the border color in the A register and storing that value, the A register, and then storing that value in the external color register. And I cannot drill into it. So the external color register is address D020, which is the border color. Don't know why it's called EXT color, but that's the common convention used in the books, the original books, the programming guides, and I think by Commodore themselves. These are the labels they've used for the register. So we're simply taking that color and putting it in the register. Pretty simple, pretty straightforward. The next is to set the background color, and we're going to set it to white. So, again, we can use these macros to set whatever color we want from the 16 color palette. Now for this one, similar concept. There's actually more than one border background color, but we're going to be just setting the main background color to white. And again, we're passing the color to the BGCOL0 register, which is the background color register, which is at D021. Okay, so that's pretty straightforward. And then we're going to fill the screen with a bunch of A's. It's just kind of a test. So notice here, though, that you have to pass at the start of the video RAM or the screen RAM, the start of screen RAM. Now, by default, let me drill into this. By default, the location for screen RAM starts at address 0400. But we've just now switched to bank 1. And bank 1 starts at $4000. Okay? But the default relative address that the VIC looks at is 0400, meaning the VIC doesn't look at absolute addresses, it looks at relative addresses. So even though now it's looking at VIC bank 1, it doesn't know the difference. It's just looking at a chunk of 16K. So it's going to be still looking at address 0400 within that 16K. But when we're filling the screen, we have to be absolute. We have to give it an absolute address. And so since we're starting at address 4000 or 4000, we have to offset it by 400 because that's where that's what the VIC will be looking at. Okay, so, and we're using the default for now. I'll show you my my memory map up here quickly. Again, the game code will reside from 1C01 3F to 3FFF. That's about 9K if needed. We have up to 9K. And then we have our VIC Bank 1, which is from 4000 to 7FFFF. And here we have basic low ROM switched out to be RAM. Okay, and then from 4000 to 43 FF is unused. From 4400 to 47 FF is our screen RAM, as we just mentioned. It's annoying, eh? All these errors. I have to figure out what's wrong. I might have to just restart VS Code. So our map data will reside here. Our sprite data will reside here. That's about 2K. And our character data will reside in here. It's about another 2K. Okay. Sorry about that. Okay. So, yeah. So we're filling the screen. Now the screen resides at, again, resides at address 4400. So we're simply passing the value we want to fill, and we're at every chunk of 250 bytes, we are putting that value up to 1000 because the screen has 1000 characters. It is comprised of 1000 characters. So there we're filling the screen. Okay. And then we have our game loop. And our game loop is just, it's a loop. But what we're doing here is, and this will become more evident in later episodes, but what's happening here is we're waiting for the raster. I won't explain this now because I don't want this video to get too long. I don't want this video to get too long. Trying to keep it under 30 minutes, but essentially to avoid tearing, we want to kind of wait for a frame to be completed and then get the next frame ready. So to get the next frame ready before it actually appears on the screen, we'll be doing a lot of stuff after this line. So between these two lines, right? Between these two lines, we'll be doing a lot of our logic. Okay. So essentially, we were waiting for the screen raster to reach 255, which is actually off the viewable part of the CRT. Right. This is where the raster line is now off the screen. This gives us a chance to do a whole bunch of things. Get our sprites ready. Do the next sprite action and things like that. So if that's not clear to you right now, I'll explain that more in the next episode, I hope, if I can remember. So that's our game loop. So now we're just going to test this. And we're going to see that everything will work even after we've switched Vic banks. Okay, everything will still work as expected. We'll see A's filling the screen. So I'm going to run this. I'm going to actually switch. You can see that in action. It takes a bit. This is a slow computer, but I'm going to be swapping out this with a brand new one. And there you go. I certainly hope you can see that. So there we go. We've just filled the screen with all A's. We've changed the background to white, the border color to blue. Quite basic. Not too exciting, but I just wanted to set the stage for the next episode. So, sorry for the bad setup, but I hope you guys liked this video, and if you did, be sure to like, share, and subscribe, and I will watch you guys on the next episode. I will watch you guys on the next episode. I will see you guys on the next episode. Take care and bye for now.